Hello everyone, this is an algebra tutorial I will be doing on plotting linear equations and finding the point of intersection. Bonus, this will include both slope-intercept form and standard form. If you don't know what those are, that's pretty important. So let me give you a quick rundown. Slope-intercept. And that is standard form, or something of standard form. So let's jump straight into the video. Here's what you need to know beforehand. It's pretty important that you know this. First, you've got to know your basic algebra, so we put that in the bottom. And you've got to know how to plot points on the coordinate plane. I find that really important if you're going to be plotting points. Just a thought. You need to know how to deal with linear equations, which I just showed you the two we're going to be working with today. So let's go to the plot. And finally, you need to know how to find the slope and the y-intercept, because those are very important, especially in slope-intercept form. I wonder. Okay, so let's start with our first practice problem. We have y equals 2x plus 1 and y equals negative x plus 4. We have to find the point of intersection of these two linear equations. Now, before we start, I encourage you to pause the video and try it on your own, because practice is the only way you can get better at math. Alright, I hope you tried the problem. We're gonna just go right for it now. I'm going to layer this. Okay. Let me rewrite this. Okay. So let's first start by graphing these two. Let me just draw a graph. Hopefully you have a graph. I would have had a graph, but I didn't draw it yet. Graph drawing ASMR is going wild. Okay, let's call this 0, 0. This point here is 0, 0. Okay? 0, 0. Okay, so our math problem was y equals 2x plus 1. So let's start by graphing the y-intercept here, which is this term. Really important because it determines how far up we go on the y-axis. So that would be the vertical line here. So it looks like we go up only 1. So this is 1. And now this is the slope. So as everyone knows, hopefully, that your slope, if it's a whole number, it's really over 1. Basic fractions. And this is rise over run. You know, change in x over change in y. Pretty important stuff. So you've got your rise, so you go up 2, and you run over 1. This also works if you negate both numbers. Helpful tip. So you can go down 2 and left 1. That's how you get a bigger line. So let me just cheat a little bit. Okay, that's line number 1. We'll call that line number 1. Make sure you draw your arrows. Arrows are pretty important. I'm not drawing it up there. The applied arrow. Okay, let me change to a different color. I love my colors. Okay, and our second one was y equals negative x plus 4. So we have to go up. Okay, not a problem. We just have to add an extra layer to our graph. Easy as pie. Well, I have to add an extra layer to my graph. You don't, because we already have a graph. If you're working. Anyway, so negative x plus 4. You go up 4. 1, 2, 3, 4. Wow, we had to add that. And this is a negative x. So really it's negative 1x plus 4. Because negative x is the same thing as negative 1 times x. So that can be written as y equals 1, because fraction, plus 4. That's 4 on y. Okay, so you go down 1 over 1 because it's negative 1 over 1. Again, this works in reverse, but we don't really have the space above the graph to do it. So we're just going to go down 1 over 1. I'm going to do this in purple. Or, I guess, pink. Because I guess the RGB world decided that the intersection between red and blue is just pink. And go down 1 over 1. And we're just going to call that the line. Because I don't have any more. Okay. That's the arrow. So obviously we already found our intersection point. I very, very beautifully, in a beautiful pink, have found the intersection point. And I realize this graph is not very good. So if this is 0, 0, this is 1, 0, this is 1, 1, this is 1, 2, and this is, our intersection point is 1, 3. Hopefully your graph is labeled so you don't have to do that. Our intersection point here is 1, 3. All right, that was a great problem. Let's do another one. This one is going to be in standard form. So let me draw a bigger graph this time, just in case. Make sure it's on the right line. Okay. While I'm drawing graphs, math tip of the day, whenever you're drawing or plotting lines, make sure to use a straight edge. They can really help you keep your lines straight so they don't look like this. That is not a good line and it confuses people. So always use a straight edge when you're drawing lines on paper. It's almost non-negotiable. Okay. Oh, I forgot that was on. I'm so smart. This is 0, 0 here. Great. Right. This is our second problem, and it's going to be in standard form. So this one's going to be a little bit more challenging, but it's all part of the math experience. We got 2x plus 3y equals 6, and 4x minus y equals 5. Beautiful numbers. I really like these numbers. Well, they're not all great, but I think they're good numbers. So let's start with the first equation here. I'm going to do it off onto the right here, rewrite the equation, and you know before we really dive into this one, I want you guys to try this problem. It's a little bit harder, gonna have to either convert forms or graph it your way, but it's another pretty difficult problem. So make sure to pause the video and attempt it. Okay, now that a substantial amount of time has passed, let's start solving it. We've got 2x plus 3y equals 6. There are two really viable ways to graph this. The first one is to graph it by its intercepts, and the second one is to convert it into slope-intercept. Personally, I like slope-intercept form, so I'm going to show that method first. Of course, you can skip to the timestamp on the screen to see the other method. So in slope-intercept form, you have y equals mx plus b, correct? Well, this equation here, 2x plus 3y equals 6, already has all those components. They're just multiplied together a little bit. So first, we want to make sure the y is on its own, so we subtract over a 2x on both sides. Remember, subtraction property of equality. So you have 3y equals negative 2x plus 6. You can rearrange this. It could be 6 minus 2x, but it's your choice on how you want to set up the equation. And so you divide it by 3. You divide the whole thing by 3. So every term gets divided by 3. Very important. So you have y equals negative 2x over 3 plus 2. This can also be written as negative 2/3 and then an x over here. Your choice. So now that we have it in slope-intercept, we can graph it. Up to, use beautiful new color. Colors. Oh, that's a great color. Up to 1, 2. And so, remember, rise over run. So we're going to go down 2 and to the right 3. So 1, 2, and down to the right 3. All right. Can we do this in the other direction? Yes, we can, it looks like. So in the other direction, you just negate it entirely and you follow that. So it would be 2 over negative 3. You rise 2 and go to the left 3. So 1, 2, 1, 2, 3. And your point would be here. Great. And if you want to know why this works, I will explain it for you. When you have a negated fraction, you can really just rewrite it as negative 2/3. It's a negative fraction. The negative sign can be either here or here because you're dividing by a negative number. It's like having a positive number times a negative number, except it's division. Really simple. You can have 2 times negative 3 and equal to negative 6, right? Or you could have negative 2 times 3 and it also equals negative 6. Because when you times a negative by a positive, it gets you a beautiful negative. So anyway, let's plot that line. That line. Okay, that looks good. Okay, that's our first line plotted. Now I'm going to go back and do it for the standard form. You can skip to the timestamp on the screen if you just want to skip to the part where I'm done. Okay, so now that we're back here, we can plot this by its intercepts. It's a really Simple method. It's honestly a lot easier than turning it into slope-intercept, but I just like slope-intercept. I am biased to slope-intercept because it was the first form I learned. So, to plot it by the intercepts, you simply set either x equal to 0 or y equal to 0. You pick one of them. So let's set 2 equal to 0. Add 3y equals 6. So this 2, it absolutely just cancels out. No more. Gone. Multiplied by 0. Pretty much. For now. We will come back to it. So we just have 3y equals 6. 3y equals 6 can be further simplified down into y equals 2 by dividing by 3. So that is where you get your y. Plot that real quick in this color. So you have y equals 2. 1, 2. Your y is 2. Nice color. Next, we have to set our y equal to 0. So we set 2x plus 3 times 0 equals 6. That cancels out. No more. Bye-bye. And you have 2x equals 6. X is therefore equal to 3, because you can divide out 2 from both sides. Usually, in a lot of problems, it divides out evenly. But in some problems, that's not the case, and those are really fun problems for some people. 1, 2, 3. So if you watched the slope-intercept form, you will know we got a slope of -2 over 3 with a y-intercept of 2. So you get the same answer, but it's just a matter of how you get it. So go ahead and plot the rest of this line. As you will notice, this point up here is still on the line. So they both get you the same answer. It just matters how you want to roll the dice, which method you want to do. Of course, if on a test, say, you were asked to use a certain method by plotting it by the intercepts, then use the method you were told to use. Okay? Don't pick and choose if you are told to use a specific method. I feel like that'd be obvious. Okay, and then we have our second linear equation. 4x minus y equals 5. Right? I showed you how to do standard form, but I'm going to do it again, just because. Okay, this time I'm just going to convert it into slope-intercept, because this one looks like it's particularly set up for it. We have a y with a coefficient of 1, albeit negative, so that will be a slight inconvenience, but other than that, we are doing quite well. Let's not have it have let's make this let's make this a 3. I don't like that number, especially because I don't have a fifth space in there. Okay, so with our new equation, we have 4x minus y equals 3. I want you to try to solve this one. Either method works. I'm going to do it when I transform it into slope-intercept. You can do it either way you want. All right, let's get right into it. We have 4x minus y equals 3. If I didn't already say it enough, blink, blink. So we have to subtract the 4x over. So negative y equals negative 4x plus 3. And then we have y equals 4x plus 3. Simple math. You subtract the 4x over, so it's on this side, and then you divide it by -1. case you were confused on how we did it. So we got this as our answer. Bad get squares. We have that as our answer. Beautiful answer. Love it for this problem. So I apologize. I made a critical error. If you caught that, you are a true picky person. We have to divide by a negative. So if you caught that, you might be IQ 180. So it only took me a few seconds to realize that I forgot to do that after I remembered to do it and forgot. Me trying to justify forgetting to drop a sign. Anyway, let's continue with the problem. With a y-intercept of -3, we just go, grab that, 1, 2, 3. This is our, let me use a different color. Purple. This is our point, and with 4x, so 4/1 is equal to up 4 and right 1, so 1, 2, 3, 4, and then over 1. Oh, ew, I don't like this. Well, we're gonna do it anyway. We're gonna approximate. And that's really all the information I can get out of this one. So okay, we've got that line plotted. Now, this is not a nice intersection, but let's calculate it out. Okay, that's not a fun calculation. If you want to look more into calculating this kind of stuff, I will probably make a video on it in the future. Not now. I apologize. Not now. But for now, let's approximate roughly. So that looks like it's a little bit less than half. We're going to call it the intersection. No, never ever do this on a test. I modified the equation here to be 3, so we could graph it. Obviously, graph the equation that is on your test. So, unless you have to calculate out where this beautiful intersection point is, you probably did something wrong. Unless you were specifically told that it's going to be an awkward answer. Let's approximate it to be something around 1, 3, that looks like a somewhat good approximation. It's not, it's over a little more than 1. It's up to interpretation is all I'm going to say. I apologize for the awkward number. That's how cookie crumbles. All right. Now let's do a really, really interesting one. This is called, well, I'm not going to tell you. It's called a special case. You're going to have to try and figure out which one it is. There are 2 special cases that are most prominent in graphing lines. So let me just recreate the graph. Recreate. Recreational sport. Okay. Now is the best time I could probably think of to promote myself. Are you struggling with a math question on a homework, or thinking about something from a test that's really bothering you that you probably got wrong and want to ask someone who is somewhat good at math? Well, I am your guy. You can ask me literally anything up to the geometry level, which is 10th grade math, pretty much. Algebra 2 level math help pending. I promise. It'll be there soon. But no, ask me Algebra 2 stuff. Up to the Algebra 2. So right now, any question, you put it in the comments. You can have Algebra, oh boy, up to Algebra 2. So I take Algebra 1 and Algebra 2. You know? So like, you've got factoring, logarithms, and imaginary numbers, which I will cover in a whole video. They're fun. And in geometry, you've got points, lines, planes, this, and circles, whatever, geometry, fun. And in Algebra 1, you've got a lot of stuff. I don't really remember. I remember, but I don't want to remember. Anyway, let's start with our final. Let's start with our final problem. Let's do this in a brilliant orange, my favorite color. Oh, that's yellow. Okay, one. Wait, no, that goes in 11 times. No. 22, yeah, 22. I'm an idiot. Alright, 4 is 1. Bring down 5. Bring magic. Magic is happening everywhere. 7, 14. 1. So 127 and a half. I found the perfect color of orange. Okay, I can't do decimals. Let's do 128 because that's the closest rounding. Okay, I'm sorry, I zoned out there doing fun math. Math is fun, but I didn't steal that from a website. I promise. Okay, enough self-promotion. Let's do our final problem. And you probably already see the similarity here. You've got numbers that are divisible by themselves. Numbers that are, well, I can't say that. Numbers that are that are multiples, factors, whatever. You notice something, right? Fraction. So let's just plot it by the intercepts real quick. 3x 2y is a bad number. Okay. I'm thinking. So let's do this first one first. Negative 2y equals negative 3x plus 4. We got x equals 3 halves plus 2, because you divide it with an x, because x's are important. Mine's the horrible handwriting. My speech is probably good enough. As I pick up the mic and speak into it, we get plus 2. So this is the first point. 3 over 2, we're going to pretend that this is 0, 0. This is 0, 0. Should have added that first. Okay, we're going to just negate the whole function over here. So down 3 over 2. So that's the line. That's the line. We're going to pretend that that's the whole. Okay, that's the line. That's the incoherent babbling. That's our first line. Let's do another color. As I give myself a seizure by scrolling through the color wheel. Let's just go absolute blue. Right across the color. Almost right across the color wheel. We're gonna call this another perfect 128, and we got sky blue. Okay, let's do some more quick math. How fast can you do it? 6 minus 4y. So you negative 4y equals negative 6x plus 10. Remember, this is a very high level tutorial, even though I'm explaining really deeply. Sort of high level. Divide by 4y. Not negative 4. Divide by negative 4. We've got y equals negatives. So from negative 4, that simplifies down. That simplifies down to 3 halves as x, and then numbers. What is it? 10 over negative 4 would be negative 2.5, right? We're going to call that 2.5 because I'm too lazy to fraction right now, even though I have decimal. I am sober. We have decimal and fraction. That's fine. Do what you will. We can convert this to y equals 1.5x minus 2.5. We don't care. 0, 0 is here. 1, 2. So that's 2. So we just go halfway. 2.5. Beautiful. Then we go up 1.5. 1, 1, and then our 0.5. And then we go over 1. Because it's always over 1. Okay, and then we just repeat the process like magic and clockwork. Boom. And you got a function. Now, if you'll notice something rather interesting about these two functions, yes, I'm going to call them functions now. I decided that they're functions because they are functions. They can be written as f of x. But that's a whole other unit that I'm not going to dive into. This is the last problem of the day, and I want to go to bed. So this is our parallel line solution, which means there is no solution. Wait, hold on. Let me look up real quick if there's... Hold on. Okay, yeah, it is a no solution. I was thinking really, really advanced math. Anyway, so parallel lines, they're special. You just write no solution. Or NS if you're feeling lazy, or if you're really lazy, you draw no slash. Literally, this golden ratio, but you rotate it. You can't, I don't know how to rotate this stupid engine. O slash. What's really cool about parallel lines is that you can do a whole lot of fun stuff with them, especially in geometry. So, God said, you stuff like transversals, all this fun stuff. Yeah, don't get me started. I love geometry. So we've got that going. So look forward to that. It's a really fun unit. Anyway, this is me, Mashed Potatoes, signing off on my first ever video. I'm gonna go have a party or something after this. Got this beautiful math. I am gotten better at drawing grids. I hope you have gotten better at drawing lines because they're pretty important. And you know what? I'm going to take this little time I have left recording to both erase this beautiful work I've done and explain some real life uses of graphing linear equations. Let me just rapid fire them. You've got architecture, math teacher, you've got nothing else. No comment. Okay, yeah. That is this video. Pretty much done. I can't draw smoke. Thank you for watching, and make sure to like, yeah, beautiful button. Make sure to like, subscribe, and I don't know, hit the bell icon if you're feeling generous. As I try to draw a bell with jingle tones. I don't know. Make sure to hit the bell tone so you know whenever I post a new video and you can learn more math. So, yeah. Thank you for watching. Make sure to like, subscribe, and hit the notification bell. And have a nice day, evening, night, or morning.